Hi guys, welcome back to NextOps videos channel. In this video, I'm going to talk about generic DevOps interview questions, which are collected from my previous experiences. I'm doing this video in English because when we attend the interviews, we usually explain our answers in English. And if I make the video in English, it would benefit a lot of people, not only Telugu guys. If you haven't subscribed to my channel already, please go ahead and do it now. Also click on the bell icon to receive the notifications. Please also share. So let's get started. So when you're preparing for DevOps interviews, what topics you need to focus on? Let's discuss about that first in next 5 minutes. And then we start with a list of questions, which I'm going to discuss. So when you're preparing for interview, focus on the source code management topics. What is source code management? We usually use source code repositories such as GitHub or GitHub related repositories, Bitbucket, Azure Repos, AWS Code Commit kind of repositories to maintain the source code. So you need to focus on this subject so that you can answer the questions confidently. You need to understand what regular commands you use in the daily basis. You need to understand the branching methodology or branching strategy. You need to understand how merge process happens when you want to merge code from one branch to another, how to handle the merge conflicts, kind of stuff. If you learn, you should be good to answer the questions around source code management. I am going to cover a couple of questions related to this topic in the next few minutes. Next thing is you must focus on cloud knowledge. It doesn't matter which cloud you have learned or you're going to learn. If you learn one of the clouds, you should be good with other clouds as well. Remember, it's just only the terminology that differentiates all the cloud services. It's not the technology. Underlying technology is similar. You need to understand what a virtual machine is called in AWS. You need to compare what an S3 bucket is referred as in GCP. So there are so many service comparison charts available in the internet with which you can compare the services between multiple clouds and get an idea. If you're comfortable with Azure, if you know the terminology in AWS or GCP, you should be able to manage them as well or explain them as well easily. Other focus that we need to concentrate on is microservices. When you're going for a DevOps interview, there would be a definite expectation around this area. So you need to well prepare yourself with Docker and Kubernetes related concepts. Understand how Docker actually works. What is a container? What are the different components of Docker? How do you troubleshoot Docker container if something goes wrong? If you learn or if you have enough idea around Docker, it would be easy to learn Kubernetes and focus on learning the components of Kubernetes, various aspects of microservices architecture, how to implement microservices, how to troubleshoot them. If you learn all these things, you should be very good to go with the DevOps engineering role or for the interview as well. The other area you need to learn is infrastructure as code, wherein you might need to focus on one of the tools which handles infrastructure automation through the coding, such as Terraform. Terraform is a universal code and which can work with any cloud in the market. There are other proprietary tools for different clouds. For Azure, they have ARM templates and Bicep. For AWS, they have CloudFormation. They are also infrastructure as code tools. But if you learn Terraform, you can work with any cloud. There is a series of videos I published on my channel about Terraform, but they're in Telugu. If you can watch them, you can understand how Terraform can be actually utilized to define infrastructure automation as code. Prepare around this area so that you will get a positive impression that uh, whatever is necessary to work as a DevOps engineer. And then automation. So you need to focus on any kind of automation. If you're coming from Windows background, might be a good idea to focus on PowerShell. If you're coming from Linux, might be a good idea to focus on Bash scripting or shell scripting. And if you are like wanted to have a common scripting engine, then you might want to focus on the Python scripting. So learning these technologies is not a difficult thing. Like we feel like it is difficult, but when we focus on them, we get an idea how to actually work with them, right? So don't waste time thinking about how to learn these technologies or how difficult they are. Just start learning them. You'll get to know how easy they are. Then infrastructure support and monitoring. So majority of the people who wanted to become DevOps engineer will be coming from the infrastructure support background. So they know how to provide the support for an infrastructure. And when it comes to monitoring, having a proper idea on monitoring tools like Nagios or Azure Monitor, Splunk, Datadog, or Kubernetes related Prometheus and Grafana, any kind of monitoring tool you take, you need to understand the purpose of monitoring and the advantages of having a monitoring tool in the infrastructure and how to create the alerts, how to calculate the capacity. So these are the main areas which will help you to take proper decisions when it comes to infrastructure by using the proper monitoring tools. So you need to have a little idea about those tools as well, because in DevOps, ops means operational activity, and the monitoring will come under operational activity only. SDLC practices. Since you're shifting your gear from IT support to DevOps engineer, you need to understand how software development lifecycle is defined, how actual development of a product happens in the organization, how testing happens, how the product will be released onto the market when everything is ready. So all this information you can gather by understanding the SDLC practices. There are so many videos out there on YouTube. Just go through them and try to understand SDLC before going for the interview, because that is a core building block for any DevOps engineer to have an idea on when working in the real time. And also you need to understand Agile and Scrum methodologies, which help you to enhance the productivity when you're working in the environment. It's not belong to only one particular team. Every team within the organization who is participating in the contribution of product development, from development team to testing team to IT team to business analyst team, maybe they have to have enough idea on Agile and Scrum methodologies so that by collaborating with other teams and working through a common platform, everybody can achieve the organizational goals easily, which we are going to discuss in the next slide. These are the just basic concepts or concept expectations from the interviewer when you're going for a DevOps engineer. But I am not saying these are the only ones. There are other tools also you need to focus on, such as the build tools, how the pipelines will be defined, how to troubleshoot pipelines. So just search through the internet, find any other useful information around this area and prepare well yourself, get ready for the interview and give it a shot. Let's get started with the questions now. So the common question that will be asked in every DevOps interview is, what is DevOps? This question is asked because they wanted to understand how comfortable you are with the DevOps. They wanted to understand your opinion on the DevOps, right? There were so many processes followed by different teams in the old days. And those processes were defined to follow certain rules by each team. Like development teams used to have their own process, infrastructure team used to have their own process. A process is nothing but a set of rules usually. But when different teams following different processes, it leads to a little bit of confusion because IT team may not be having idea about development process. Development team may not be having idea about IT team process. If that is the situation, it leads to friction between these teams. They will start blaming each other when some issue comes into the picture. That's where DevOps came into industry and solved so many issues around it. DevOps become a standard practice in almost all organizations these days. Hence, it is referred as a culture. It's not a process. And this is a culture followed by development teams, IT teams as a common practice. What are the advantages of having DevOps in the organization? It brings both teams, development and operation teams, together to achieve organizational goals successfully. Back in the old days, every team is following their own process, or every team was following their own process. That's where the friction originates because of lack of transparency. And if something goes wrong with the application, the development team used to blame the IT team used to blame the development team. If there is enough transparency between these teams, people from dev team can see what has been done by IT team and vice versa. And this transparency can only be achieved by the tool set because tools will log everything. And DevOps is a culture which extensively uses tool set. And these tools exposes whatever it has been done by any team, any person within the team. So if any changes done by the development team, they will be exposed to IT team. If any changes done by IT team, they will be exposed to development team. So everybody will be on the same page and there will be no friction at all. There is no chance for blaming each other. So DevOps streamlines the standard practices for both of the teams so that they can follow it and improve the productivity and reduce unnecessary friction. So this is what you need to explain. First, you need to understand what is DevOps, why it is important to follow the DevOps within the organization. The next question is, what are the principles of DevOps? What are the principles of DevOps? It is continuous integration, continuous deployment, infrastructure as code, automation, and monitoring. So as I mentioned in the previous slide, DevOps brings automation practices with the help of different tools. DevOps brings transparency with the help of different tools into the organization. So now, when a product is being developed, usually the development team writes the code, and this code will be pushed into a source code management repository, and the code will be then handed over to the build team so that they can run the build process, and then it will be deployed onto the infrastructure. So this was the manual process back then. But now, with the help of DevOps, entire effort, what we have discussed, has been automated now. Continuous integration means anything at all that changes within the code will be immediately integrated into the build process. And with the updated code, the build will be run. Once the build is successfully completed, with the latest output or the artifact, deployment happens. That is what it is called as continuous deployment. So within an organization, if a team of development is working on code, then they do make changes to the code multiple times a day. Once they're done with the changes, they will push it back to the source code management repository. Why do they change the code in the first place? There could be n number of reasons for the addition of new features, or for the enhancement of existing features, or for fixing any kind of bugs. That's why they do the code changes, right? So now if I wanted to see if the bugs are fixed, or if the features are enhanced, or if the new features are added or not, then I need to run the build process and then deploy it onto the environment so that I can see those reflected changes within the application. With the help of DevOps, this process will be streamlined through automation. When the developer modifies something, the code will be pushed into repository that is called as continuous integration. And once the code has been received by the repository, it will run the build process automatically through the pipeline. So updated output will be generated. Then the same will be deployed onto the infrastructure. So the development team can see the updated changes in the real time. Also, IT team can also see the changes in real time. That is what the benefit of continuous integration and continuous deployment. As part of this effort, we might need to prepare the infrastructure for deployment activity. We might need to create a couple of virtual machines or web apps or Lambda functions or Azure functions, whatever it is, to have a platform to run the deployment artifact or the build artifact onto the environment. That's where infrastructure as code automation comes into picture. Once this is done, then we have to monitor that for any outstanding issues or any performance issues or any security issues kind of stuff. That's where the monitoring comes into picture. Give me a few popular tools of DevOps. The DevOps actually started off with one of the stable pipelining tool called as Jenkins. And this is used to handle the CI/CD efficiently. And this is an open source tool that came into the market in between 2014 or 2015, around 2014, 2015. And it was there before then, but it got popularity during that time. It is similar to Azure DevOps pipelines, AWS DevOps pipelines. Git is a source code management repository where you can maintain the source code developed by or written by the development team securely and safely. And also you can maintain versioning for the source code. So it is a central storage for all your source code to be saved successfully. And then tools like Jira help you to track your work, manage your work, plan your work, etc. It is a ticketing tool. It supports agile methodology. And there is Azure boards in Azure DevOps, which also does the same thing. Ansible is a kind of configuration management tool with which you can actually configure your infrastructure through automation. Terraform is to deploy the infrastructure. Ansible is to configure the infrastructure. So through Terraform, if you deploy one of the VM, and inside the VM, if you want to make any configuration, you can achieve that using configuration management tools like Ansible, Chef, or Puppet. Terraform, as we discussed, this is an infrastructure as a code tool to automate the infrastructure deployments. You can list these tools when they ask something like, give me a few popular tools of DevOps. Next question is, explain about IAC and configuration management tool that you worked. IAC stands for infrastructure as code. Few people call it as IAC. So don't get confused. If they ask about IAC, it is infrastructure as code. So you can say that you have worked with Terraform if you have learned it already. If you haven't learned it already, just go through the Terraform series videos and try to learn it so that you can start working with and explain. So infrastructure as code tool is to streamline the infrastructure deployments. You can write some code to deploy infrastructure components like virtual networks, virtual machines, storage accounts, or VPCs, EC2 instances, S3 buckets, etc. Since you can maintain the infrastructure as code, you can also maintain this code within the source code management repository where the original application code resides. You can also bring the version control mechanism for your infrastructure code so that you can see what has been changed recently within the infrastructure by looking at the previous version of the code. Then CM tools. CM stands for configuration management. You can mention Ansible, Chef, or Puppet. I'm sorry for the spelling mistake there. It is Puppet as CM tool if you have enough knowledge. So configuration management tools, as I said in the earlier slide, they help you to configure the infrastructure. Once the VM is deployed through Terraform, and once it is entered into running state, then you connect to the machine and then execute any automation scripts to configure that machine according to the business requirements. Let's say that VM you have deployed through Terraform has to be turned into a web server. Then you need to either install IIS or Apache Tomcat or Nginx server on top of it. This installation, this configuration can be achieved with configuration management tools. Go back and watch a couple of videos on Ansible or Chef or Puppet so to understand how these tools actually works. Configuration tools usually help you to avoid any configuration drift. Configuration drift means usually IT team follows certain best practices to deploy the infrastructure and they standardize it through templates. Once a server has been built as per the best practices and once it has been handed over to a respective team, they will try to make certain modifications on the server which may cause issues. They will not do it intentionally or unintentionally, but due to the lack of the knowledge, maybe in some cases, they might disturb the standard configuration within the server so that it will not perform as expected. If you establish configuration management tools, they monitor the configuration within the server and they will avoid any configuration changes by reapplying the standard template or standard configuration template onto the server again and again. Let's say a server has been built and it has been applied with a standard configuration template. After that, it has been handed over to a team. They logged into the server, they made certain changes into the configuration. What Ansible does is when the configuration change has been detected through a scheduled job or something, then it will understand that the standard configuration has been changed. It has to bring the configuration back to original state. So it will try to reapply the configuration template again. So whatever the changes which has been done by that particular team will be reverted back and the server will be brought back to stable configuration. Thus helps us to improve the stability and performance within the server. That's where this configuration management tools comes into picture. What is Scrum methodology? Scrum is a framework for project management commonly used in software development. It is used to divide complex software development tasks into smaller chunks using iterations. So it's just a methodology, it's just a practice. I mean, it's just a set of rules followed by all teams who are involved in development activity or support activity or operations activity. With this approach, what happens is the entire effort will be split up into small chunks of tasks, and it will be scheduled using um, multiple iterations, and each iteration will be referred as a sprint. A sprint is usually a 2 to 3 week period in which these teams will schedule the outstanding work with the use of ticketing tools like Jira or Azure boards. And these tickets are the small chunks of tasks. That's what we refer them as tickets. Scrum teams usually consists of 3 roles. One is product owner, whoever is actually owning the product or given the requirement to us to work on, he will be part of Scrum. And then Scrum Master, who will be monitoring entire effort, how the committed work is going on. Is it going as per the schedule? Are there any roadblocks that needs to be addressed by the product owner? Is there any delay? Or are there any backlogs? Scrum Master will usually handle Scrum meetings on daily basis. They call them as stand-up calls, in which every team member will explain the status of his work, and if he is facing any issues, that kind of stuff he will explain, so that Scrum Master will note down everything and take it back to the product owner so that he can address if there are any issues he can address, he will do that. And the regular teams which involves in the development and operational activities. So Scrum methodology is a streamlining process to handle complex product development activities by splitting up into smaller tasks and scheduling them into multiple iteration called sprints. What is version control? It is a system that records the changes to a file or set of files over the time so you can recall specific versions. Let's say you have created a text file. So when you created it, it is the version 1. From there on, whenever you make changes, all these changes will be recorded by the version control system, such as Git or Bitbucket or Subversion or Team Foundation version control by Microsoft. So anything or everything that is being happening on this simple text file will be recorded as a separate version. If something goes wrong with this file in the future due to bad content or bad code, then you can simply revert back to the previous version. So version you can think of like a snapshot. Just do not compare it with the snapshot, but it just help you to go back in time so that you can roll back whatever the issues occurring due to the bad code in the latest version. You can go back in time, you can revert back to the previous version. But in order to record all these changes, we need to have a certain process or a system to handle recording of all these changes. That is what it is called as version controlling. In the real time, what happens is usually a team of development will be working on coding effort. So they will create multiple files as part of the coding. They will write the code and they keep on adding code to the code files. Whenever they make modification, they push the code back to central code repository, such as GitHub or Azure repos. Whenever they push changes, GitHub automatically record those changes and maintains them as a separate version. If the updated code is causing problems, they can revert back to the previous version of the code where the application was working fine. And it is only possible with the version controlling systems like GitHub. That's where it helps us to solve a lot of issues in the real time. The version control system consists of central shared repository where teammates can commit the changes to a file or set of files. That's what I'm talking about. So a team of people working on a development activity, then they make modifications to the code and push it back to the central repository. And whenever a push happens, it is called as a commit. And these commits will be maintained as commit history. And if anything goes wrong with the latest commit, then they can easily revert back to the previous commit, resolving the issue immediately if it is necessary. Because they will be bringing the application back to previous state by reverting to the previous commit. Usually, version controlling system allows you to do the following things: to revert the file to previous state, to compare changes over time, to revert the entire project to a previous state, to see who modified something in the files. Because Git also provides a comparison mechanism where latest commit and previous commits can be compared. And it will also show us the differences between both of the files. What new code has been added to the latest commit, what is missing in the previous commit. So we can understand by looking at the code files from the previous commit and latest commit, and try to resolve the issue very easily. What is the branching strategy in Git? Usually, when the code is being developed, it will be pushed into a central source code repository such as Git or Azure repos. Branching in source code management repository is like creating a separate line of development wherein, let's say, for example, the team started working on a project and they have created a central repository in the GitHub. When they do that, GitHub will create a master branch initially. And all the team members will be working on the code development, and end of the day, they will be pushing all those changes to the master branch itself. So all those changes will be maintained in the central repository. They did this for about 2 to 3 weeks, and they came to a conclusion that whatever has to be done within this sprint has been completed, so they can release this code into production. Now, after 3 weeks of effort, the build will be run and extensive testing will be handled. They'll thoroughly test the functionality of the application, and then they will deploy this output onto the production environment so that people from the external networks like internet can consume this application or use this application. That's what happens. Now they have released version 1 of the application and it is working perfectly fine. So as they released version 1, they will not stop with development process. They will continue with the development process. They will keep on adding new features or keep on fixing the bugs or keep on enhancing the current features. And they don't want to disturb the existing code. So what they will usually do is they will create a new branch out of the master branch. Master branch is having the code which is very stable and which has been released into the market. They don't want to disturb that. So they simply create a new branch and they will start working on this branch for the second release. So this branch holds whatever the code changes which has been done after the release 1 and provides the same functionality as master branch. So branching is a very efficient way of streamlining the development process. Usually organizations follow branching strategy by creating future branches or bug-based branches, which means they create separate branches for each future development. And once the future development is completed, at the end of this code development, they will merge all these branches into master branch so that all those developed features will be integrated into the main application. And once the application has been released, then users will give some feedback saying that this particular feature is not working properly or it is throwing an error, something like that. So those are called as bugs. In order to fix these bugs, again, like they will create branches based on the bugs and separate that code from the rest of the code using the bug branches and try to fix the code within those branches. So either they follow feature-based branching strategy or bug-based branching strategy, and few organizations also follow release-based branching strategy. Go through the internet and look out for some information. What is a branching strategy and most used branching strategies, and prepare well before you go for the interviews. Next question is, how do you undo last commit in Git? It's just a technical question. Last commit means, so now development team has done some modifications and they wanted to push this code back to the central repository. How they will do it is, they use a command called git commit and then git push to upload this new version of code to the central repository. I will explain about Git in a new separate video, all the Git functionality, so that you get idea. Maybe in the future I will do that. So please do subscribe and share to receive the notifications whenever I publish. So coming back to this question, when a developer pushes some code change using the git commit, git push command, and after pushing it, if they realize that the commit, whatever they have done, or the push that they have done is not efficient or it has some code issues, then in order to revert the commit back, they can use this command, git reset head 1 or git revert and the commit ID. So this is a technical question around Git and most usually asked. So that's why I included this question. Just go through, maybe try to find out what this does actually when you issue these commands. Maybe find out a couple of other articles and try to understand in detail. Next question is, what is cherry picking in Git? Usually, as I said, there will be multiple branches when you when the development team is working on coding effort. So whenever they do code modifications, they will push it back to the central repository and to the respective branch, and that is called as commit. Now, let's assume that they have master branch, future 1 branch, future 2 branch. The development team is working on future 2 and they made enhancements to future 2 related code and they wanted to push all this code back to the future 2 branch. But accidentally they have pushed it to future 1 instead of future 2 branch. Now, how do they handle this situation? How do they undo the future 1 commit and again do the commit back to future 2? Again, like using the git revert command or git reset command, we can undo on the future 1 branch and then commit again onto the future 2 branch. But instead of doing all that, there is a feature called cherry picking, with which what you can do is you can remove that commit from future 1 branch and then attach it to the future 2 branch simply. So cherry picking is the act of picking up a commit from a branch and applying it to another branch. Git cherry pick can be useful. That is a command, git space cherry pick. Git cherry pick can be useful for undoing changes. For example, say a commit is accidentally made to wrong branch. In our example, future 1 branch. You can switch to correct branch and cherry pick the commit to where it should belong. So you have to go to future 2 branch and cherry pick the commit from future 1 so that the commit will be successfully added to the future 2 branch. So these are the few questions I prepared for Git, maybe very important questions. And then what is a pipeline in DevOps? In my opinion, a pipeline is a set of tasks, and these tasks are used to automate certain effort, like pushing the code back to repository or running the build process or deploying the artifact onto a particular environment. So a pipeline will be divided into multiple steps or stages in which you define tasks, and these tasks automate entire effort, right? So a pipeline is a set of tasks which allows DevOps team and developers to reliably and efficiently compile, build, and deploy their code to their production compute platforms. So pipeline will help you to compile the code, build the code, and deploy the code. So you need to pick up respective tasks to handle these efforts. You need to pick up a compile task, you need to pick up a build task and a deploy task. All these tasks will be executed sequentially in a order. So it is a task sequence. A pipeline is a collection of tasks which follows a sequence and enables automation of entire effort. In simple terms, what is automation in DevOps? DevOps usually encourages automation for everything. It actually encourages you to or enforces you to automate everything. There shouldn't be any manual intervention for any of the activity within the DevOps. So automation in DevOps improves speed of development. Agility means speed of development, and consistency, accuracy, reliability, and increases number of deliveries. Because we are using automation, which means we are using tools. So these tools will help you to speed up the entire effort. Okay. And then as we are automating everything, there is no manual intervention or there is no chance for human errors also. When do you want to automate anything? When you are performing the activity multiple times or repeated times. If you automate a repeated activity, then it will reduce the time of that activity because it is being handled by tools instead of human beings, which obviously improves the speed of activity, that is called as agility. For automation, you can leverage various automation tools. Azure DevOps, it's an automation tool, or you can write some scripts to automate certain tasks which are not natively available. You can use PowerShell, Python, Bash, or shell scripting to automate operating system specific activities or application specific activities as well. What is a build in the DevOps? The build is a combination of certain tasks like compilation, testing, inspection, and deployment. When the developer pushes code back to the repository, depending on the application framework, a build tool will be used. If it is Java application, usually Maven, Gradle, Ant-like tools will be used. If it is .NET based application, Visual Studio or MS Build like tools will be used. For Python, Ruby, and other languages, they have their own build tools as well. So building is nothing but taking the code from the repository and compiling it, testing it, inspecting it, and deploying it to the environment, such as production environment. In the build process, all the source code from different modules clubbed together to produce a single workable unit called as artifact. So usually artifacts will come out of the build, and this artifact could be an executable like an exe or a DLL or a jar file or a var file or a Ruby gem Python file, could be anything. And when we deploy this artifact onto an infrastructure, it will run as an application such as a mobile app or a web application. In the deployment, we will take this artifact from the build, that is build pipeline, and then we will deploy it onto the infrastructure such as virtual machines, web apps, or whatever it is. Explain about few deployment patterns. There are standard deployment patterns followed by industry these days called as blue-green deployments, canary deployments, rolling deployments. So now there is a production application running already, which is giving business to the organization. And on top of it, business wants to enhance the functionality or come up with a new version so that it can include new features. So in turn, it will attract a lot of new customers, right? So when the new release is going to be, new version is going to be released, they have to do it carefully. If they do it without proper testing or proper planning, it will impact the existing application, which leads to business interruption. So when version 1 has to be replaced by version 2, there are different deployment patterns that usually followed. In blue-green deployment pattern, what happens is a separate infrastructure will be maintained for old version and new version. The old version of the application will be running in blue environment and new version of the application will be running in green environment. With the load balancing technologies, organizations usually divert or redirect the users to blue and green environments. So few people will see old version of the application, few people will see green version of the application or new version of the application. So once they get enough confidence, then they will switch green version to production and remove the blue version. So version 2 will be continued, version 1 will be removed after thorough testing and feedback from the users. But in this case, there is a lot of cost involved because we have to maintain two infrastructures separately for each version. But this is the safest mechanism to bring a new version of the application into production because it doesn't involve any downtime at all. When we decide that version 2 is working fine, we just decommission version 1 and version 2 will continue to operate normally. And the next deployment pattern is canary. In the canary effort is you don't create two infrastructures, you only maintain one infrastructure, but create two deployments within the infrastructure with version 1 and version 2. Using the load balancing technologies, you redirect your users, certain percentage of users to version 1 and certain percentage of users to version 2. And after you receive thorough feedback from the users that the version 2 is working fine, you gradually increase the percentage of user redirection to the newest version. Let's say initially 90% of the traffic will be sent to version 1 and 10% was sent to version 2. Once you get enough confidence, you reduce the percentage of traffic to version 1 to 80% and increase the traffic to version 2, that is 20%. You will handle this gradually. So at some point, 10% of the traffic will be sending over to version 1, 90% of the traffic will be sending over to version 2. And after that, 100% traffic will be redirected to the version 2 deployment. Then you can safely remove version 1. But in this case, you don't need extra infrastructure. It's just using some set of tools, you can handle the traffic redirection to old versions and new versions. Rolling is like you deploy version 1 to certain percentage of infrastructure and you leave the rest of the infrastructure as it is. Let's say, for example, you have 4 machines which is running the version 1 application. What you will do usually is you will keep the version 1 on 3 machines and update the 4th machine with version 2. And after you get enough confidence, you will increase the number of machines which are supporting for version 2. So you make it to 2. Then version 1 will be running on 2 machines, version 2 will be running on 2 machines. After some point, you increase the machines to 3 for version 2. And after final conclusion, you will increase the machines to 4. So version 1 will be completely removed. So these are the different deployment patterns to handle switching between different versions without, the main focus is we need to reduce the cost and downtime. So we need to select the best approach. Out of these three, canary would be the most useful situation. Canary will be used. And investigate a little bit more information about these deployment patterns in the internet so that you will get a clear understanding with all those images as well. What are the phases of DevOps methodology? There are 5 phases involved in this as a common practice, starting with planning of the effort, how to tackle this development activity, how many days do we need, how many people we need to support this development activity, all the planning, by what date we can deliver this particular application. Everything will be done within the planning phase. And then once the planning is completed, they will come up with sprint schedules. And once the sprint is decided, they will start developing the application. And as the development progresses, testing also happens parallelly. And then after the development is completed and testing is completed, deploy it into the production environment so that the consumers can access the application, helps the business to grow. Then once the deployment is successful into the production environment and it is running perfectly fine, it is the operational team's responsibility to support the infrastructure and the application for any issues. In order to avoid any kind of other issues, we need to involve some monitoring tools so that we can monitor the infrastructure and application as well to avoid any kind of unnecessary surprises. So these are the different phases of DevOps methodology. Just explain them in simple words, like a single sentence or 2 sentences. That would be enough. Just need to remember these phases of DevOps. That's all it is. Next question is differentiate between continuous deployment and continuous delivery. I guess this would be the last question for this video. So deployment, continuous deployment. Usually DevOps is referred as CI/CD. CI means continuous integration. CD means continuous deployment or continuous delivery. Some people call it as continuous deployment, or some people call it as continuous delivery. So what is the difference between this? Continuous deployment doesn't involve any kind of manual intervention. Everything after the build is successful, everything will be handled through the automation with the tool set. No manual intervention at all will be involved when you follow the continuous development process practice. Whereas if you follow continuous delivery, at some point in the execution of the pipeline, after the build is completed, before it is getting released into the production, some kind of manual intervention should be required, like reviewing the code, testing the code, approving the deployment to the production. So somebody has to come in while the pipeline is getting executed. Somebody has to come in and click on approve button manually to continue with the rest of the pipeline execution. That is called as continuous delivery. In continuous delivery, manual intervention is there. So monitoring will be automatically there. The same can be achieved with the tools. In Azure DevOps, they call it as gates. So if you use gates, it's an automatic process. We don't need to wait for someone to come in and approve. So that's called as continuous deployment. So that's all for this video, guys. In this video, I have discussed about, I think 15 generic interview questions around DevOps, as I said in the beginning. So in the next part, I will cover more questions if it is possible. So please do subscribe if you haven't already, and also click on the bell icon to receive the notifications. And if you have any other questions in your mind, please post them on the comment section so that I will help you out giving the answers, and also include them in the future video so that everybody will get benefit out of it. Thank you so much, guys, for watching this video and giving a lot of support to my channel. See you in the next video.